Hello everyone, welcome back to the YouTube channel of Developers and Coders Club. Today we are here to discuss the problem, the very beautiful blanket, which came in recent context of Codeforces. So, what is asking in question that we need to form a size and into a matrix such that for every submatrix of 4 into 4 should follow a condition. And what is that condition? That for every 2 into 2 matrix of this, XOR value of this matrix should equal to XOR value of this, and XOR value of this should be equal to XOR value of this. What I need to say that we need to form a n into m size matrix in which for each submatrix of size 4 into 4 this condition should follow, and that condition is this submatrix of size 2 into 2 XOR value of this should equal to this, and XOR value of this should equal to this. So there can be multiple solution for this, but we need to find the best solution which we can find in easiest way. So what can be a basic intuition that anyhow if we make such a matrix in which for every 2 into 2 submatrix XOR value of this is equals to 0. If we find such a matrix, then for every submatrix size 2 into 2, that XOR value of that will be 0, and this condition will always follow that XOR of this will be equal to this will be equal to this, because this is also 0, this is also 0, this is also 0, and this is also 0. So now our target is we need to find a matrix in which for every 2 into 2 submatrix XOR value of this equal to 0. So if we like make a matrix like A B C D E F G H I J K R. Here, what I need to say that uh, if we form a matrix like this, then XOR value of this should equal to 0. XOR value of this should equal to 0. Again, XOR value of this should equal to 0. Then again, XOR value of this should equal to 0. Same XOR value of this should equal to 0. Like how any much 2 into 2 matrix we can form, XOR value of that should be 0. So if we discuss for this, then I need to say that XOR value of A, B, G, H should equal to 0. XOR value of B, H, C, I should equal to 0. And XOR value of C, I, B, and J should equal to 0. Then for D, J, E, K should equal to 0, and so on. So if we start from a basic like 4 into 4 matrix, then if we select numbers from 0 to 15, we can select more than 15, but just for making it easy solution, we are selecting from 0 to 15. So first of all, let me make a 4 into 4 size matrix. Okay. Then I'm writing numbers from 0 to 15 in binary form. So, so I have written all binary forms from 0 to 15. So, okay. Then if you notice a property, that what we need to form, that we need to take four numbers such that XOR value of that should be 0. So if you notice from this to this, from this to this, XOR value of these four is 0. Why? Because for first bit the even numbers are 1 here, and for second also even numbers are 1 here, and for so on. So XOR value of these four are 0. Again for these four, that is 0. You can see 4 ones are here, 2 ones, 2 ones. XOR value of these four 0, and XOR value of these four also 0. So we have choose four numbers such that XOR value of that is 0. But we also need to select some numbers which are intersecting in both, and XOR value of that is 0. So for this, if you notice these four, then XOR value of for these four even numbers of 1 are it. because two ones and again two ones. So XOR value of these 4 is also 0. Then XOR value of these 4, that is also 0. Then XOR value of these 4, that is also 0. So what I need to say, that if we fill up this with 0, then this with 1, then these two with 2 or 3. But how we can fill that? Like I want to say that we can fill like 0 1 2 3, or we can fill like 0 1 2 3. But if we fill like this, then what I will make in our code, that start from this, start from a node, then go down, then go right, then go up, and then go left. This is the intuition we are following. But in this, what we are doing, we are going this, then diagonally, then this, then again diagonally. So that will be a little bit harder. So I am selecting this one. So 0 1 2 3, then 4 5 6 7, then 8 9 10 11 12 13 14 and 15. This can be a solution for 4 into 4 matrix. If you see for any matrix like this, then check for XOR value of this, then 2 5 11 12. So for 2 that will be 0 0 1 0, 0 1 0 1, and 1 0 1 1, and 1 1 0 0. So okay, here are even ones only 2, here again even ones, here again even ones, and here again even ones. So XOR value of this 0. So if you check for any sum matrix of size 2 into 2 in this matrix, XOR value of that will be 0. But there is a condition that every row, like if I talk for a 0 based row, then for every even row, that should start from a power of 2, like 0, 2, that can be 16. But if that is not starting from power of 2, then there will be a mistake. Like just think that there is an additional column. Then we write 8 and 9 here, and here will be 10, 11, here will be 12 and 13. Oh, 12 and 13. Because 10, 11, 12, 13. So if you check for these four, then 1, 2, 10 and 13. So 410001, 0010, 1010, and 1101. Okay, so here you can see only one are there. That is odd. So XOR value of this will be 1, and for that this will be 0. This will be 0. So that is not a non-zero XOR. So that is a wrong answer. But if we check for previous one, that will be 1 2, and here was 8, and here was 9 10 11. So if you check for this, then 41 0 0 0 1, 0 0 1 0, 1 0 0, and 1 0 1 1. Okay, so XO even ones, even ones, even ones, even ones. So that is 0. So that is a condition for this, that for every even rows that should start from a power of 2. So if we take input from row and column and then form a matrix for this, and also following that condition that should start from a power of 2, that will be a little bit complicated. So for making that is a solution, what we can do, just tell me that if I form a 16 into 16 matrix, okay, and obviously that will follow that condition because size of this is 16. So if there is 0, then we are adding 16 here, so that will be reached till 15, and this will start from 16. Then again 16 plus 16, that will reach 31 here, then we are starting from 32. So if the size of matrix is power of 2, then obviously always that will start from that will satisfy our condition, and that should start from a power of 2. So this is following our condition. Then just tell me that if I select a matrix something like this, then that will be also follow our condition. What is our condition? That for every size 2 into 2 size matrix, XOR value of that will be 0. So if that is following this for this matrix, that condition is followed, then obviously for this also will be followed. So what we can do, we can make a global matrix and from that taking input for R and C, and we will print a matrix of R and C from that global matrix. Okay. So what can be size of our global matrix? In our question, it is given that uh, this value of n and m is lying from 4 to 200. So for global matrix that can be 200 into 200, but as you can see that is not a power of 2. So what is the number after 200? That is a power of 2. That will be 256. So our target is to make a matrix of 256 into 256. Following this condition that we can do a variable starting from 0, then fill first cell, then go down, go right, go up, go left. Then again follow that procedure, that go there and so on. Okay. And when we reach on our endpoint, then what we will do? Increase our I with plus 2. Then we will jump here and J 0. Then will come here. So after making this global matrix, what we will do? We will take input for R and C, and we will print from I to R and J to C, and print this global matrix I and J. Okay. So let's see the code part that will make a little bit understandable. So what we are doing, that we are first of all we are making a matrix of size 260 and 260. I'm size is 260, but we are doing only 256. So what will be the maximum value of curve? We are starting from 0, so that will be 256 into 256. So till then we are initializing our mat with that curve, increasing that, and then I'm making a flag variable that will go like what we are going to do, down, up, right, left, so on. So if I plus plus, that means uh, this is our matrix. We are here. So if value of flag is initially 0, then what we are doing, we are increasing our I with plus plus. So that means we are going down. This is I and this is J. Then if value of flag is 1, then we are doing like after that I am increasing our flag with plus 1. So after the here value of flag is 1. So I am doing that J plus plus. That means we are coming this side. Then flag of 2, then I minus minus. Again there. Then flag value of 3, then J plus plus again there. And in finally I'm taking flag with flag plus percent 4. That means if value of flag is 4, then that will be automatically 0. Then again 0, 1, 2, 3, and so on. And if we are reaching here, value of j is more than or equal to 256, then increase our I with plus 2 and j with 0. This is our global matrix made, and here I am taking input for n and m and printing till n and m. So code part was not so much difficult. Difficult part was just understanding that what we are going to do, like how we can make a 2 into 2 sum matrix for each sum matrix XOR value of this 0. So that was a pretty basic solution about this problem. I hope you all understand it. See you in the next problem. Till then, happy coding. Bye bye.